workshop today is called Improving Feeder Reliability and Increasing Operational Efficiency by using the GridShield recloser. My name is Alfredo Romero. I work out of the Lake Mary facility. That's where we manufacture the reclosers, outdoor breakers, indoor breakers, and switchgear. So our agenda today, the main goal of the training, of the workshop today is we know most of you are at an inflection point. You're gonna be needing to upgrade infrastructure. So decisions you're making today are not only, okay, what equipment do I buy now, but also if the equipment I'm gonna buy, is it gonna be good for my needs in 5, 10, 15 years from now? So the idea is to outline what are the challenges the industry is facing, what are the requirements that you need in order to meet those challenges, and show you how the GridShield recloser actually helps you meet those challenges. So we're going to be talking a little bit about those challenges, the smart grid requirements, some of the features that the GridShield recloser gives you to meet those challenges, such as communications and hardware, the ability to implement a lot of smart grid applications. We go through some of those applications. So as I mentioned, what are the biggest challenges facing the utilities? Basically, the power grid, the most advanced technical achievement of the 20th century, not only because it powered our homes, but also provided the lifeblood that allow us to increase our knowledge, spur the innovations in the computing and communication technologies. So I'm pretty much it's been consistent in the 20th century. In the last 20 years, we've seen a lot of changes. For example, and they varied. They are technical, economical, political, environmental, and now we are in a position where, in order to face those challenges, we have to change the way we, design our power grid, how we manage it. So it's changed drastically. And some of those things are reliability and security. 2 minutes of an outage 30 years ago was probably an inconvenience. You didn't watch your favorite show. Nowadays, there are industries that could be shut down, like whole production line could be shut down for only 2 minutes. We are more sensitive to even flickering lights, security. If there's an attack, taking down the electricity could actually have a bigger impact economically than a long time ago. I don't know if you guys heard when there was a solar storm that a lot of people were talking about in the news that it might affect our power grid. That happened 80 years ago, and it was not even in the news because it didn't have an impact in the economic impact in society. So reliability is very important, and those are the drivers that that utilities like PREPA and other utilities around the world are facing. Okay, we have to make decisions now and to address reliability and security, operating inefficiencies. There's an outage, somebody calls you, you have to send a truck. How long does that take you? So, it's not only an issue of customer satisfaction, but it has actually a direct impact on your bottom line, your cost, number of crews you have. So this is something you need to consider also as you upgrade your equipment. Obviously, you have an outage, you're not making any money, so loss of revenue and decreased customer satisfaction. So how do we address those things? And support of emerging energy sources. Historically, we can generate a lot of power at a coal plant, for example, and we transmit it through our transmission lines down to end user. Now we have that, but also have distributed generation. So now we have might have bidirectionality in the power flow. Our customers implementing, or some utilities are putting demand response. So the utilities are now participant on how they use energy. So the way not only the utilities are generating and transmitting power is changing, but also how our customers are using it is changing. So and that's what I was referring to now. To meet those challenges, reliability, operational efficiency, increase your bottom line, and supporting all the emerging technologies that are coming up as far as generation of energy, are forcing the utilities to be at inflection point. So now we have all these trends. How do we face those challenges in order to be better, to change the way we operate? We've seen utilities embracing all of the changes at the same time. There's always pros and cons for every approach, but what we've seen in the market, you have utilities that say, okay, we're going to make a lot of investment, we're going to make them all at the same time. Or utilities are moving a little bit more cash, slowly, so they doing pilot projects or doing deployment of smart grid technologies on different phases. And there are other ones that are just waiting. Now, let me see how things work out. I want the vendors to work out all, the integration challenges and so on. So I'm going to wait it out. But regardless of where you're at, you have to make decisions that are gonna, or that hopefully, when you make the investment, those decisions will allow you to keep on deploying technologies and supporting your requirements of not only today but also of the future. So what are some of the smart grid trends? So that was kind of like an overview of where we are right now. But when we talk about smart grid, the first phase of a smart grid deployment, and for most of us, the first time we heard about smart grid, it was associated with smart meters. And as you see, this is on the x-axis you have cost, then on the y-axis you have benefit. If you see, it was cost and time. The AMI took a while, because there were new technologies that need to be implemented. It changed in the mind frame of a lot of our customers and the vendors. So now the next phase is, if you see here in the graph, is distribution automation. So they've done a lot of studies where they've shown that the actual payoff and return investment on deploying distribution automation technologies is a lot higher than deploying AMI. And when I talk about distribution automation, I'm talking about self-healing grids. So that's going to be a little bit more focused today. Fault detection, isolation, restoration schemes, automatically reconfiguring the system, isolating the faults. But also you have volt-var optimization. Some of you might have already seen some of the products that help you with volt-var optimization, CVR, conservation voltage regulation, and so on. So that's kind of where the recloser fits in on the distribution automation side. So basically that's the next phase of smart grid deployment. And in that trend, this is where the recloser fits. So again, going back, your challenges are reliability, operational efficiencies, supporting emerging technologies, and improving customer satisfaction, reducing loss of revenue. So your product still, in addition to having a lot of, advanced features, it still has to be reliable. It still has to have features that help you reduce your operating costs, your maintenance costs. So, for example, this is our GridShield recloser. The high voltage cabinet, has a material. I'm going to spend most of the time talking on the controller, but some of the benefits, and these are some of the basic benefits you're still looking for, regardless of the advancements in technologies, you're still looking for a product that is reliable. One of the things on the high voltage cabinet is that it doesn't have any electronics on the high voltage compartment. Therefore, that eliminates, if there's a surge, a voltage surge in the circuit or lightning strike that affects the UPS, all the key equipment that drives the actuator resides on the low voltage cabinet. So if there's any issue, anything you need to replace, or anything you need to maintain, or batteries, for example, you have batteries that you might need to replace, all of that resides on the low voltage cabinet. Therefore, improving reliability. If you have to work on the high voltage side, then it requires you to send 2 people, a crew, get a permit, and so on. So all the cost and time that implies. And in addition, you have modular poles. So in case for some reason there's a tree that hits one of the poles, it's modular. It's a modular design. So all you have to do is take 4 bolts, and you can take out the pole on the field and replace it. Also, there's a 24-pin cable that basically is a plug-in cable. So it wires right into the control cabinet inside of it. So this eliminates any need for wiring, because if it's inside, it also eliminates the ingress of water or tampering, somebody messing with the cable. So that cable resides inside. So again, these things, basic features that made from a utility point of view, I'm expecting to get a product that gives me reliability, reduces my operating cost, my maintenance cost, and is easy to use and install. And then on the low voltage cabinet, The main feature is the RER620 and the controller. And I'm gonna go through some of the features again that, I talked about the inflection point where you might find yourself today, where I need to buy a product. How does that fit into my needs of this year, 2 years down the road, 5 years down the road, 15 years down the road, where I don't know what kind of applications I might need to be deploying. So some of the smart grid requirements, regardless of the vendor, you have, I know I've spoken to many of you, depending on the region, there's no one solution for the one utility could say, I'm going to use wireless radios throughout my system, because it's not, in some cases they might be using cellular technology, or you have public networks versus private networks. So there's a lot of options out there. So one of the keys is to, when you look into making your investments, you have to get a product that supports integrating your product with any type of communication network that you might be installing today, that you have in the present, but also that you might be looking at in the future. For example, like the communication card, you have an Ethernet port. If you need to deploy technologies that are based on IP, RS-232 cables, RS-485 ports, serial, fiber. So in general, any technology that you might need to implement today, you can also support future trends or future technologies. We have a customer, for example, that the current radio network is serial, and they go into IP technology because of the features, the speed with which you can pull information and the different type of application you can deploy on an IP-based network. But they're not ready for that yet, so they purchase radios that have serial and IP. So they're going to be plugging into the serial port, and in the future, when they're ready to deploy the IP network, they just disconnect the RS-232 cable and plug in an Ethernet cable. So that's kind of one of the main things that you have to look at. My communication network that I have today works fine for now. In the future, I have a lot of applications that I could deploy on top of that communication network. And I'm not only talking about FDIR schemes, but also volt-bar optimization. So when you decide what kind of communication network you're deploying, there's some other things to consider. What kind of application I can deploy on this network? And having the flexibility to do that with any type of communication technology, it's great, because then you don't have to worry about, okay, I made an investment today that 6 years down the road, 10 years down the road might not work for me. So staying on some of the other smart grid requirements, open protocols. I have some slides where I go through some applications, so a lot of these will come together. But again, one of the keys is having open protocols. The reason for that is that makes you, a lot of the vendors, ABB included, when we design a product, we have to ask, okay, what are the requirements? There's money you have to spend on developing proprietary protocols. For example, ABB had a proprietary protocol before. And the reason is why don't we decide, we want to keep on doing that? Because we see the industry moving towards open protocols. That makes it easy from the utility point of view to deploy different technologies and interface with different products along the line. So you have reclosers, you're going to have switches, you might have pad mount switches, fault current indicators. All of those, if they support open protocols, basically unlocks all of a sudden a lot of great applications that can help you, again, improve your reliability and your customer satisfaction, and support a lot of the emerging technologies. So this port, for example, the RJ45 port supports simultaneously DMP 3.0 and 61850. So DMP 3.0, for example, you have your DMS or your communication gateway, the substation, your SCADA talking DMP 3.0, you can plug it in to that port. And if you deploy other devices that have 6150 capabilities, and when I say 6150 on the distribution network, I'm talking about a particular application of 6150. As you know, 6150 is a standard. As part of the standard, there's boost messaging, but basically allows you to do peer-to-peer communication. So once you deploy your communication network, even if you're not using it right now, you're not thinking about doing peer-to-peer, you plug in your controller, you're going to have to connect to SCADA. So you plug it in, you have the support of open protocols, and then later on in the future, if you want to deploy peer-to-peer communication, that same port can support up to 5 clients. You could be connected to your SCADA network or your DMS and to 4 other devices down the feeder or upstream that support 6150. So again, communication and having the flexibility to, does this equipment meet my needs today? But okay, what about the future? Can it support some of the applications that I might have in the future? And on the hardware, you also might find yourself on applications where you might need to have 6 voltage inputs on both sides. So you need to have the hardware that supports that type of application, 6 voltage inputs, and you might need, you might have applications where you need to use PTs because you need a lot of accuracy, or you have applications where all you need is, 1% accuracy, so you can use sensors. So you need to have a technology that, without adding any additional hardware, allows you to interface with instrument transformers. Or if I don't want to use instrument transformers, I want to use sensors, then this technology for example, the voltage input card supports putting any type of voltage sensing equipment, whether it's a PT or a sensor, without adding any additional hardware. Also, time sync. How many of you heard about time synchronization or looking at doing that? So, for example, I used to work at a utility, 10 years ago. They never thought about putting radios in the reclosers. The communications was for the substations, transmissions, and now pretty much looking at a recloser without communication, it's basically it's one of the main requirements. When you put it on the spec, that's one of the main things you pay attention to. The same with time synchronization. We have a lot of customers. Actually, one of our local customers here in the Houston area, they're using time synchronization. So you put a GPS clock to time sync, the clock in the relay. And why is that important? Because then it helps you, after you have a fault, to do a lot of the analysis. What happened actually. You look at the oscillography, and you can indicate, okay, what happened in the system. So it helps you troubleshoot your network once you have a fault. Also helps you with load profiles. What's my load? So it gives you a lot of benefits. So the communication card also supports on this RS-45 port. There are 2 pins that can be configured to support time synchronization. So if you don't need it today, but in the future, that's some application that you might be implementing. The hardware again also supports that. So again, the message is the whole communication capabilities, flexibility to connect to any communication network, having open protocols. That way you can deploy applications not only among reclosers, but also between different devices that you might be putting in your system, such as reclosers, switches, fault current indicators. So having the flexibility to implement any kind of technology is very important. So talking a little bit about why are these requirements important? Now, I talked about communication, flexibility, open protocols. So why is that important? You could start deploying distribution automation schemes, and pretty much a lot of customers might fall into one of these 4 categories if they consider doing FDIR schemes. FDIR schemes is fault detection, isolation, restoration schemes. So you might be on a device level, based on voltage. You might be going to peer-to-peer communication using obviously communications, or substation control, or we call distributed control. So you have a gateway at the substation that collects all the information from the remote devices and has the logic to perform a switching, restoration, that does a lot of calculations to see what's the best route to restore power. Or centralized. And when we say centralized is, a DMS system that looks at the whole system. So I'm going to go through some of those applications. So for example, so this is a typical, your substation. You have your 2 breakers at the substation with IEDs. And then outside of the substation, you have a sectionalizing recloser, a midpoint recloser, a tie point recloser, and the same on the other feeder. So for example, you have a fault here between the sectionalizing recloser and the midpoint recloser. Again, this is a voltage-based automatic restoration scheme, so you don't need any communications. We have a lot of customers that actually implement that. And the important part here is to have two things. You have to have voltage inputs and the logic embedded in the device to perform this logic, to perform execute the restoration scheme. So if you have a fault here, once the fault happens here, obviously this sectionalizing recloser will go through the 4 shots or 3 shots that you've programmed it to. So you have 1, 2, 3, let's say 4 shots to lock out. After the 4th shot, it goes to lockout, and this PT or VT on the midpoint recloser has basically senses the loss of voltage. So that kicks off a timer. So you have timers. So all these devices have timers, and you pre-configure them before you deploy it. Once the timer on this one expires, it changes. I think you can go in the next one. So if you see after the timer expires, it changes to alternate settings, and it turns a function that blocks the reclosing. And the reason is because then after the timer expires on the tie point recloser. So this tie point recloser has 3 sensors on both sides, on the source side and on the load side. And that was when I was talking about some of the features you need to have, having 6 voltage inputs, for example, because in this application you need to have 6 voltage inputs. So once the timer expires here, this one will close. So if you go to the next slide, this one will close, and you'll basically detect the fault again. And because you've changed to settings and you have the right coordination, this one will detect the fault. It automatically trips, so it won't go to lockout. It won't do the reclosing sequence because it turned on. After the timer expires, it changed settings to have the proper coordination, and then it blocked the reclosing. So it detected the fault and it went to lockout automatically. So that's voltage-based schemes, or loop automation. So the same case could be implemented using Goose. And I say Goose, it's part of the peer-to-peer specifications of the 6150 standard. So you deploy your communication network. So you have your radios connected to each ID on the network. And basically the same case, if you have a fault here, okay. So this one goes through the reclosing sequence, 1, 2, 3, 4, after the 4th shot, it stays open. The difference now is like once it stays open, it sends a message to this device saying, listen, I detected a fault, I went to lockout, I want you to have that information. So this device publishes the lockout message. And Goose is a little bit almost like a radio station. You have your antenna, you're driving in your car, and you have all the radio stations going through your antenna, and then you filter that signal, and you only pick up the signal you want. So the way with Goose messaging, basically what you do, you program the relay so certain devices on the network publish messages, and other devices subscribe to those messages. So this one, when it sends a lockout message, it sends it to the network, but not all devices are subscribing to that. Only the ones that need to have that information. So in this case, I go to a lockout. This one receives the lockout message, and this other one receives the lockout message. Once this receives the lockout message, if you can go to the next slide, it opens up automatically because it knows the fault. If my upstream recloser received a permanent fault and I went to lockout, it means that there's a fault upstream. So I'm not gonna reclose into it. I'm just gonna go ahead and open. And this one, once it receives the lockout message from the sectionizing recloser, which detected a fault, and receives another Goose message with the breaker status from the midpoint recloser, because it basically is waiting to, okay, I had a fault upstream, so I lost my main source. But I don't want to close it until I'm sure I've isolated the fault. So once it receives this breaker status via Goose message to the communication network, it receives that, and then it closes and isolates the fault. So now, I talked about peer-to-peer or device-to-device, so voltage-based and peer-to-peer schemes. And again, a lot of these decisions, a lot of customers are putting the IP network. So once you deploy it, you're looking at, okay, I'm right now I'm concerned with just deploying my communication network the way I can do remote and close operations, and I can pull metering data, I can pull certain data, and then later on they can start deploying the other applications. Some of the applications right now have this, what we call substation based. So you have a gateway at the substation. In this case, we have a COM600, and through your communication network, the only key part is that all these IDs on the network. Right now I have GridShield reclosers with RS620, but if you have a switch in the tie point, as long as he supports open protocols like a DMP, 6150 or Modbus, then you can talk back to a communication gateway. That communication gateway gets all the data and basically sends, and on top of the communication, it also has a PLC that has the logic that performs the auto, the isolate, not only the fault detection. The fault detection is done automatically by the recloser based on curves and protection, settings. But then the isolation and the restoration is done by a device at the substation. So in the same case, you have a fault here. This one goes to lockout and sends through the network a lockout message to this device. Then this device says, okay, now based on the logic that you've put in there, then it will say, okay, I want to isolate first. So you isolate, through the network. Then this device will send a trip signal to this recloser. This recloser, once it opens, it sends a breaker status message through a DMP, for example, back to this device. And then this device, now when it has confirmation that this one has closed, is tripped, then it sends a close signal to this device. So it's pretty much sending similar to Goose messages, but obviously you're sending through your DMP, or you're basically going back to a substation gateway to perform the logic instead of being peer-to-peer. This slide is just a screenshot of our DMS software. And the only reason I wanted to talk about this is because we talked about device logic. So voltage-based, peer-to-peer using Goose messages, substation-based using a communication gateway and a controller, or you can go to a centralized. So all of these applications work, but they're all based on what are your requirements, where you want to go in the future. And the whole point for a centralized obviously requires communication. It's a higher investment, but obviously takes into consideration the whole network. So not only you do the reconfiguration, but also later on you could perform algorithms to optimize your volt bars, your power factor, and so on after you've actually isolated and reconfigured the system. But the key message is that regardless of where you are right now and where you're going in the future, a lot of the communication capabilities of the relay and a lot of the hardware supports basically any type of FDIR or distribution automation scheme that you might be needing in the future because of the Ethernet ports, the protocols that it supports, like open protocols like DMP 3.0, 6150, that allow you to actually deploy any level of automation that you might be needing today, but also in the future. This particular example, this is actually an application that one of our customers is deploying. And I just wanted to show it because actually it's a hybrid of using substation-based control and peer-to-peer. And this customer in particular has distributed generation. So you have your distributed generation, your transformer, and your interconnection point. So one of the applications they have is actually this recloser detects the fault. And obviously once it detects a fault, it trips. And once it trips, it actually sends that trip signal to a communication gateway, the substation and a controller. That communication gateway actually then, once it's tripped, it sends a direct transfer trip to the interconnection point. Because obviously if you have distributed generation here and you have a fault, if you don't trip that DG, you're gonna create you're gonna basically feed your customers with your distributed generation. So the transfer trip actually goes from a controller to that device using DMP 3.0. At the same time that it sends that signal to the communication gateway, via peer-to-peer communication, because it's the same network that they're using. It's the cloud that is just going to a substation gateway. It actually sends a signal upstream to basically disable your pickup, your 50p, because for coordination, once you put distributed generation, coordinating a lot of reclosers becomes really hard. So what they find out, if actually they just do a feeder, doing the feeder coordination by just blocking. If this one picks up the fault, it automatically will block the fast overcurrent elements on the upstream device. So it helps you improve, feeder coordination, because it becomes really tough. Once you start adding a lot of devices out there, this is one of the things I was talking about. One of the challenges is obviously reliability. You have the recloser, but also supporting emerging energy resources or energy sources like distributed generation, wind farming was in this case. So you work on the reliability, but also supporting a lot of these emerging trends. So this one says, my 50p-1 picked up. Who's interested in getting that message? So basically this message goes to this one, to the one upstream, and says, I'm interested in that because I care about the coordination, so I'm gonna subscribe to that message. So via goose messages and peer-to-peer communication, it blocks all instantaneous, elements on this upstream recloser. So in this case, you could still share, you could actually do transfer trips between this device and this device. Once this one detected fault, it can initiate the trip signal to the interconnection point. And when this one opens up, it sends a status message to this RER620 saying, allow me to reclose. So I don't know if that was clear enough, because obviously if you don't want to, if you have four shots to lockout, you do your first shot and you don't want to close on a fault, or you don't want to close on a fault that is being fed by the distributed generation. So you're waiting on the distributed generation to be out before it allows you to do the reclosing. So the customer is doing this using peer-to-peer communication, the interlocking, but actually the transfer trip, they going back to a substation gateway. So it goes back to having the flexibility to deploy different types of applications that support, your reliability requirements and needs, but also supporting different technologies that are coming up in the future. So they were having tons of problems with coordination. That's one of the reasons they want to use peer-to-peer communication to do the feeder coordination here. Applications are important, obviously. What kind of, I'm going to use distributed logic, I'm going to use a DMS, what kind of communication network I'm going to be deploying, how I'm going to do time synchronization. Those are all key questions that you need to answer. But at the end of the day, once you get an equipment, you deploy it on the field, then you face other challenges. Like how easy it is for the operator to use this equipment. So regardless of how advanced the technology is, it still has to make sense for the operators to use. And it has to make it easy, because that also has an impact, like in your system, for example. So you're in charge of, once you put a recloser, it's your baby pretty much, right? So you have to, there's a fault, you send your crews out there. Now how easy it is to use, right? So we develop a lot of features on the recloser to address precisely that. And mainly, I would say, there are three. The main one is, if you have a fault on your network, your recloser went to lockout. It's 3 o'clock in the morning, you send your crew out there. A lot of the things that they would do is like, okay, I need to give the engineers in the morning or at night the events. So what happened, right? You also need to download oscillography records, waveform. Well, if your technician is not dealing with reclosers every day, one of the main issues, at least what I found out from different customers, is one of the hardest things is actually just to communicate with the device, because you have to have the latest software version. You have to make sure that it matches. You have to have a special cable. You have a customer that basically he hang with a box of cables, the different manufacturers, and he's driven 2 hours and found out that he didn't have the right cable. So those little things could affect your cost and your speed with which you respond to your customer outages. With the front port the relay has a front port, RJ45 port with a web server. All that means is basically I could take your computer, the one that you're looking at, as long as you have a web browser, I can pull out my web browser, use a standard Ethernet cable that I can buy at any store at any time, just the blue ones that you see in your offices, and you plug it in, the relay, you plug into your computer, open the web browser, your IP address, and boom, you can connect to the unit. So this screenshot here is a little bit hard to see, but this is pretty much how it looks. And you have these different tabs. Your operators most likely will be downloading events, so they go to that tab, or downloading records, oscillography records, and it has obviously different access levels. So if it's an operator, it allows you to read, download records, but it doesn't let you change settings. If you're an engineer, it allows you to change settings, but it doesn't let you operate the recloser. So there are different access levels that you could provide. But again, the key is that it doesn't need any special software, no special cables, and it helps you increase the speed with which you can actually connect to a unit and basically troubleshoot your network and get your customers back up and running a lot quicker. The second one is the faceplate customization. So you have 16 push buttons and 11 LEDs. And one of the things that I personally, when I started working with the recloser factory, I said, well, it's pretty cool. You could program the push buttons, but I quite didn't see too much the benefit of it until I went to a customer, and literally they have, like, one of our push buttons says ground block enabled. So you push if you push the push button, you basically enable the ground block. In their system, the operators are used to, when they push the button, they actually disable the ground block. So these small differences, when when talking about having an issue on the field, the operator is already used to something. So the benefit of having the flexibility to program the push button is that we could actually take all these push buttons and LEDs and program it in a way that is easier for your operators to use. So we could sit down with you and say, okay, what are your operators are used to now? So we could change the LEDs allocation, how they're configured, the push buttons. Obviously the labels are configurable, but we can actually program a lot of the logic, on the faceplate to make it easier for your operators to use. And the last one, the flexibility to implement any kind of logic. So the relay uses a software called PCM600 that is standard on all of our Relion platform. So you have Relion, we have the REI620, which is the recloser controller, but we also have feeder, the REF615, which is for feeder protection, RET for transformer protection. They all use the same software. But the software gives you a lot of flexibility. I just took a screenshot of how the software kind of looks. So it's basically a GUI. So it's very easy, very intuitive. And it allows you to implement any type of logic. And some of the benefits, for example, the co-load logic that comes default with our relay might not be exactly the way you handle it. So if you need to change your operation procedures because our logic is a certain way, that obviously has an impact on your operations. So we can actually sit down and program the logic to make it, match what you're already using. And again, it helps you, reduce those costs of, now I'm putting something new that I know is great because it's gonna allow me to deploy a lot of smart grid applications, but it's now hard for my operators to use. So these are some of the 3 things that we put into the design to make it, again, easy for the operators to use and address some of the issues that you're having. On top of being worried about the new emerging technologies that you need to support, you're always going to have to worry about cost, right? And operational efficiencies, how easy it is for your operators to use the equipment. So again, overview of a smart grid-ready recloser. Open protocols that have the common standard on the controller. The reason for that eliminates any need for future upgrades. If later on you need IP network, you don't have the IP or the RJ45 port, the Ethernet port, you might need to get a serial to Ethernet converter. So that means more money, more cost to you, but also you're adding another device that could decrease your reliability, right? The more devices you're putting in any system, you decrease your reliability. So you have all the ports, all that support any type of communication interface that you might be doing today or in the future. Open protocols, so it helps you deploy any type of application that you may be needing today and in the future. I show you a couple of slides where you could do a hybrid of different applications based on how you stage your deployment. So you don't have to worry about being locked to a particular technology. You can actually deploy a lot of the applications as long as you have open protocols and you have the hardware that you need to deploy these applications. Again, reducing operating and maintenance cost. Obviously, doing a lot of these FDIR schemes allow you to improve your reliability because you reduce the number of outages, the number of customers that are out, the speed with which you restore your customers, and obviously you isolate the fault quicker. You can send your trucks a lot quicker to find where that fault was and fix it. So it helps you reduce your operating costs, maintenance cost. And the last two, basically things that make it easy for you now, regardless of the technology. The web HMI interface. You can have a software, but if it makes it easy for the operators to connect a lot quicker, it helps you, solve a lot of the issues you might have in, doing troubleshooting or just performing your operations. And on the recloser as a whole, having a recloser that obviously is reliable. You're still going to need to have an apparatus that interrupts the current regardless of the technology. So having a product that has been proven in the market that reduces your maintenance requirements, it's key. Well, thank you very much.